Imagine, if you will, a world so close to its star that it's being ripped apart, atom by atom. A planet so hot its atmosphere is boiling away into space, creating a cosmic tail like a comet. This isn't science fiction. This is the grim reality for a real-life exoplanet known as WASP-12b. Today, we're diving deep into one of the most extreme and fascinating worlds ever discovered, a place where the line between planet and star begins to blur. Get ready to journey 1,400 light-years away to witness the dramatic final act of the planet that's being eaten alive. So, what exactly is WASP-12b? Discovered back in 2008, it belongs to a class of exoplanets called hot Jupiters. These are gas giants, similar in size or even larger than our own Jupiter, but they orbit their stars at an incredibly close distance. And when I say close, I mean shockingly close. While Earth takes a leisurely 365 days to orbit the Sun, WASP-12b whips around its star in just over 26 hours. That's right, its entire year is just a little more than one Earth day. This blistering pace means it's locked in an extreme cosmic dance, one that is slowly but surely leading to its demise. Its parent star, WASP-12, is a yellow dwarf star slightly larger and hotter than our Sun. The proximity of WASP-12b to this stellar furnace has some mind-boggling consequences. The planet is tidally locked, meaning the same side always faces its star. Just like how the same side of our moon always faces Earth. This day side is perpetually baked, reaching temperatures estimated to be over 200 degrees Celsius, or about 4,000 degrees Fahrenheit. That's hot enough to melt steel and vaporize most known materials. In fact, it's one of the hottest exoplanets ever found. The night side is cooler, but still incredibly hot by our standards. This extreme heat is just the beginning of WASP-12b's problems. The real drama comes from the immense gravitational pull of its star. Because it's so close, the star's gravity tugs much more strongly on the side of the planet facing it than on the side facing away. This differential pull, known as tidal forces, is stretching the planet out of its spherical shape. Instead of being a nice, round ball like Jupiter, WASP-12b is distorted into a bizarre egg or teardrop shape, bulging towards its stellar tormentor. It's literally being pulled apart at the seams. This stretching has a catastrophic effect. The planet's atmosphere, superheated and puffed up, can no longer be contained by its own gravity. The star's gravitational pull is so immense that it's actively siphoning material directly from the planet. Gas from WASP-12b's atmosphere is being pulled away into a massive stream, flowing from the planet and feeding directly into the star. Imagine a cosmic waterfall, but instead of water, it's a torrent of superheated gas being devoured by a star. Astronomers using the Hubble Space Telescope have actually observed this phenomenon. They've detected a huge, distended cloud of material surrounding the planet, a telltale sign of its ongoing destruction. This cloud is so large that it makes the planet appear much bigger than it actually is when observed at certain wavelengths of light. This process of a star consuming its planet is known as stellar cannibalism. In the case of WASP-12b, it's losing mass at an incredible rate, about 6 billion metric tons per second. While that sounds like a lot, and it is, the planet itself is massive, about 40% more massive than Jupiter. So, it won't disappear overnight. However, the clock is ticking. Current estimates suggest that at this rate, WASP-12b has about 10 million years left before it is completely consumed by its star. In cosmic terms, 10 million years is the blink of an eye. We are witnessing the final fleeting moments of a planet's existence. But the story of WASP-12b gets even stranger. One of the most surprising discoveries about this planet is its color. You might expect a scorching hot planet to glow red or orange, like hot metal. But WASP-12b is the opposite. It is, and I quote the researchers, as black as asphalt. It reflects almost no light that shines on it, making it one of the darkest known exoplanets. Why is it so dark? Scientists believe the extreme heat on its day side prevents clouds from forming. Without clouds to reflect starlight back into space, the light simply penetrates deep into the atmosphere where it's absorbed by hydrogen atoms and converted into heat energy. It's a perfect light trap. This darkness only adds to its menacing, otherworldly character, a giant, black, egg-shaped world being slowly torn asunder. The composition of its atmosphere is also unique. While it's primarily hydrogen and helium, like Jupiter, observations have detected a surprisingly high amount of carbon. In fact, the carbon-to-oxygen ratio appears to be greater than 1. This is unusual, as in our own solar system, including the Sun, oxygen is more abundant than carbon. This high carbon content has led to some incredible theories. It suggests that WASP-12b might be what's known as a carbon planet, or a diamond planet. On such a world, under the right conditions of temperature and pressure, the abundant carbon could form exotic landscapes of graphite, tar, and perhaps even mountains of diamond. While we can't see the surface of this gas giant, it's tantalizing to imagine a core of pure diamond, a treasure hidden within this dying world. Studying a planet like WASP-12b is incredibly valuable for astronomers. It's a real-world laboratory for understanding extreme planetary physics. It pushes our models of planetary formation and evolution to their limits. How do hot Jupiters get so close to their stars in the first place? Do they form there, or do they migrate inward from farther out in their solar systems? The fate of WASP-12b provides a glimpse into what might happen to other planets in similar situations, and it helps us understand the complex and often violent interactions between stars and their planets. It's a living example of planetary end-of-life scenarios. Furthermore, the techniques used to study WASP-12b, like transit spectroscopy, are the same ones we'll use to search for signs of life on other, more Earth-like worlds. When a planet passes in front of its star, a tiny fraction of the starlight filters through its atmosphere. By analyzing this light, we can determine what gases are present. On WASP-12b, we find vaporized metals and a high carbon content. On a different planet, we might one day find oxygen, methane, and water vapor, the telltale signs of a habitable world. So even in its death throes, this dark, doomed planet is lighting the way for future discoveries. So, as we gaze out into the cosmos, let's remember WASP-12b. It's a stark reminder that the universe is not always a serene and peaceful place. It can be violent, chaotic, and utterly unforgiving. Planets are born, they live, and in cases like this, they die a spectacular death, consumed by the very star that once gave them light. It's a dramatic cosmic story unfolding 1,400 light-years away, a story of a planet being eaten alive, a dark world stretched to its breaking point. We are privileged to have the technology to witness this incredible event, learning more about the universe with every bit of data we collect from this dying giant. Thank you so much for joining me on this journey to the edge of planetary destruction. It is truly humbling to think about the incredible diversity and extremity of worlds that exist out there. What do you think is the most fascinating part about WASP-12b? The fact that it's egg-shaped, as black as asphalt, or that it might be rich in diamonds? Let me know in the comments below. And if you enjoyed this deep dive into the cosmos, please hit that like button and subscribe for more adventures into the great unknown. We'll see you in the next video.